Yesterday we had a geology department faculty retreat, so we do this at the beginning of the semester to sort of figure out our game plan for the year. And at 1:51 after lunch, while we were sort of talking about things, we all of a sudden noticed the shaking. We were on the second floor in James Blair, and there were 8 of us there. We sort of exchanged looks, and then exchanged looks again, and like, that's an earthquake. And really the second sort of thought we had was the shaking continued, probably counted to 20 before the shaking stopped. And that's pretty much the hallmark of a significant earthquake. And so right away we're like, this is not a small little magnitude 3 event here in Virginia. This was bigger than that. And so the very next thing we did, instead of diving under the tables, immediately we were sort of on our electronic devices trying to figure out what had actually happened. So there are about 3 or 4 different ways geologists would measure the size of an earthquake. But this local magnitude, sometimes called Richter magnitude, is one that's used and sort of recognized. So for better or worse, that's what we got, 5.8. And then that certainly ranks up as sort of the largest one that's been recorded on instruments in the state of Virginia, and certainly ranks right up there as the largest that we've probably had in historic time. Well, these are old faults, old faults, and these faults were probably first active during the collision which made, in essence, the Appalachian mountain range. The earthquake that happened yesterday occurred along a fault within the North American tectonic plate. So what we've got is a situation where these tectonic plates aren't as rigid as we might sort of teach in an introductory geology class. The idea that you have these rigid blocks that are sliding around and jangling into one another. It's quite possible that this was sort of a once-in-a-century kind of earthquake in the Appalachians. But I think the important thing about it is that it did cause local damage, and it wouldn't have had to have been much larger, and it would have caused sort of regional damage. I've talked to a bunch of our students, and many of them felt them, but certainly not all of them felt it. And I think the ones who didn't feel it sort of feel ripped off. I think some people feel like they lost their opportunity, and 20 seconds is not a long time, but probably for most of us it'll be the biggest thing we sort of experience from that kind of shaking in Williamsburg. One of the things that we do in the geology department here at William & Mary, and we think we do it really well, is we get students engaged in meaningful research. And I've had students working on the Spotsylvania Fault and the Lakeside Fault as part of their senior research projects in Virginia. And I think we've learned a lot about that region. But I'm pretty jazzed up about doing more. I mean, obviously, there's a real seismic hazard here, and it's hard to evaluate, but that's sort of why we do research. And one of the things that come out of academic research like this is potentially something very tangible about earthquake hazards associated with this sort of zone that until yesterday, no one except a few geologists really sort of put much stock in.